Hello and welcome. This video is an introduction to the Weldon V-MUX electrical system. There can be up to 32 nodes in a V-MUX network. Each node has a numerical ID, such as node 1, node 2, node 3, etc. The nodes are blank from factory, so they must be programmed outside of the vehicle before installation. Nodes can be reprogrammed in the network. An invalidated node can be programmed in the network, as long as only one invalidated node is connected. There should not be two nodes with the same ID. This problem is usually caused when vehicles have two displays, and a USB stick is used to load the designs into them. Place only the binary file for the specific display in the base directory of the USB stick. V-MUX is different than a CAN-based network, such as J1939. V-MUX is a low-speed network, running at 9600 baud rate. CAN is high-speed, usually running at 250 or 500k baud rate. A VDR, high-content node, or a new 8x16 node is required to translate CAN to V-MUX. It's very important that terminating resistors are not used on a V-MUX network. CAN requires the resistors, but they can cause problems in V-MUX networks. Here are two oscilloscope waveforms showing V-MUX network signals, with and without terminating resistors. The top waveform has the resistors. You can see that during the off time, the voltage is about 0 volts, and the overall peak-to-peak voltage is less than the network without resistors. The bottom waveform shows a proper V-MUX signal, with no resistors installed. During the off time, there's about a 2.6 volt bias. The communication chips need this bias for reliable operation. It is possible to read this bias with a DC voltmeter, but it can vary, depending on the number of nodes. Terminating resistors on the network can cause a loss of messages. A common symptom would be where the warning lights are enabled, and all of them turn on. When disabled, some will turn off but others stay on. That means that at least one node missed the message to turn those lights off. Other possible causes of that same symptom might be water inside one of the three-way splitters, or a single open communication wire somewhere in the network. The network uses three-way splitters. The 3-pin connectors to the splitters have keyed wedge locks that are green, orange, or blue. To keep the network organized, the wires with the blue wedge locks should be connected to the trunk line that goes from splitter to splitter, and the green or orange connector from each splitter will drop off to the nodes. The V-MUX network should have a 4-pin network tap connector to allow easy connection of the V-MUX transceiver for diagnostics and downloading. Weldon recommends the use of the blue jacketed V-MUX network cable, which is easy to distinguish from other networks. The shield wire should be grounded in only one location to prevent a possible ground loop. It should be connected on pin C of all the splitters, but not tied into the rest of the nodes. V-MUX is a command-based system. There are two types of commands, digital or analog. A digital command is simply on or off, and an analog command is for variable data, such as temperature or amperage. Each command has a specific ID number. There is a command database that correlates command numbers to names. This database is split up into 6 different markets: fire rescue, recreational vehicle, trade show, military, bus, and marine. Our focus will be on the fire and rescue market. The database is further split up into command categories, such as emergency commands, door switches, interior or exterior lighting. Each category has individual related commands with intuitive names. The scene left command is in exterior lighting category, and will be used for our example. The scene left command is ID number 170. It is not important for technicians to know the command ID numbers, only the command names. The scene left switch is connected to a node 1 input, and the scene left light is connected to a node 3 output. When the switch is turned on, node 1 will send command number 170 onto the network, with an on status. This message is sent only one time. All other nodes will receive the command and register it as on. Any node that uses that command will respond accordingly. In this case, node 3 will activate the output to turn on the scene left light. The command state will remain on until that same command is sent again with an off status. It is important to note that a command can be sent from any node in the network. All nodes react to the last command message that was sent, regardless of its origin. We'll enable the node 1 switch again, and the light will turn back on. If node 2 has a scene left button, you can use it to turn the command off again. Once node 2 sends the off command, all nodes will register the command as off, including node 1, which at this point still has an active switch connected to the scene left input. If the switch is turned off, The scene left command will be sent again, in an off state. Since all nodes already register that the command is off, no outputs will change. There are 3 pieces of software that go into each node. The bootloader is internal firmware that is installed at the factory. It allows the node to accept the program binary files. The design binary tells inputs and outputs how they are supposed to function. This file is compiled by the vehicle builder, and cannot be altered by others. Design binaries are truck-specific. The node operating system or OS file provides functions and features of the node. These files get updated from time to time. Generally, there is no need to reload nodes every time a new OS file is released. In order to update the OS in a node, you must also load the design binary file. It is possible to reload the design file without updating the OS, but the V-MUX downloader program will not work unless the OS files are installed on the computer. This concludes this video lesson. To learn more about the Weldon V-MUX system, please proceed to the next lesson. You can contact Weldon at 800-989-2718 if there are any questions.